Good afternoon and good morning. My name is Trent Reed, and as Chair of Technology Professionals Canada, or TPC, it's my pleasure to welcome you to today's webinar. We're just going to give a few minutes for some of your colleagues to join, and I'll be right back. Thanks. All right, good day, everyone. Again, my name is Trent Reed, CTech, and I serve as the Chair of Technology Professionals Canada, otherwise known as TPC. TPC is an alliance of provincial engineering and applied science technology professional organizations whose primary function is to better protect the Canadian public by regulating and conducting the conduct of engineering and applied science professionals. TPC's mission is to engage national stakeholders and undertake national initiatives as directed by its provincial member organizations, and our vision is to be the national voice of engineering and applied science technology professional organizations. I'm pleased to welcome you today to today's webinar on the role of AI in shaping the future of engineering, insights, tools, and practical tips. The webinar concept was developed as part of the national activities to celebrate National Engineering and Applied Science Technology, or NEAT Week, which is an initiative of TPC, and there are activities taking place all week on both the national and provincial level, with the intention of highlighting the valuable contribution and certified engineering and applied science technicians and technologists make to the engineering community and to our provincial and national economies. Earlier this week, we held a national capstone competition webinar, and I am pleased to congratulate the winning team from Sheridan College, Mr. Vikram Pandey and Hugh Roy Staples, for their excellent presentation. Today's webinar will be recorded, and a link will be available to the recording on the NEAT Week landing page of the TPC website. Before we begin, I would ask you to join me in acknowledging that this land has been a site of human activity for thousands of years. We honor and respect the diverse Indigenous peoples connected to the territories from which each of us is joining the meeting today. We recognize the enduring presence of Indigenous peoples on this land and express our gratitude for the opportunity to live, work, and gather here. We are committed to understanding and acknowledging the histories, cultures, and contributions from Indigenous peoples, and we strive to build positive and respectful relationships. As we engage in our discussions and activities today, let us carry forward this acknowledgement and commit to working towards reconciliation, understanding, and collaboration with Indigenous communities throughout the country, and to continue the stewardship of the land we all call home. So let's get today's webinar underway. It is my absolute pleasure to introduce our presenter, Michael Carter. Michael is a researcher, consultant, and podcast host and professor of applied science and computing at St. Lawrence College in Ontario. He is the co-founder of an AI-powered platform designed to help teachers help students. He is currently writing a book on the strategic adoption of AI in post-secondary institutions and is a LinkedIn top voice on artificial intelligence. Michael, we're looking forward to your presentation this afternoon. We will have a bit of time for questions at the end of Michael's presentation. However, we do encourage you to enter them at any time throughout the course of the webinar in the Q&A box at the bottom of your screen. Michael, over to you.
Good afternoon and good morning for those folks that maybe are still in a morning time zone. Trent, thank you very much for the warm introduction. It's much appreciated. It's an absolute honor to be invited to address the community today. I'm quite excited and still riding high on the energy of meeting Geoffrey Hinton, the godfather of AI and recent Nobel Prize winner in Toronto a couple of days ago. So I've got a lot of energy and excitement, and I'll try to keep myself contained throughout these slides. Today I'm going to talk about AI and engineering, and at the end there will be time certainly for some questions. And if I can't get to them all, I encourage you to reach out to me directly. One of the ways that you can reach out to me, of course, is on LinkedIn. As Trent mentioned, I have the honor of having an artificial intelligence top voice badge for the moment, which is really neat. This QR code, if you have your cell phone handy, you can scan the QR code with your phone, and that will take you directly to my LinkedIn profile. I welcome you to connect with me there, and I'll try to drop the link in the chat at some time before the conversation ends as well. So a little bit about me. As Trent mentioned, I'm a LinkedIn top voice for AI. I'm a bit of a futurist. I'm a bit of a founder, a bit of a creator, and a bit of a consultant, as well as a professor proudly at St. Lawrence College here in Kingston, Ontario, where I am absolutely having the time of my life, working with students in applied science and computing. How did I sort of enter into the spaces? I have a background training in surveillance studies, particularly in the spaces of social media and smart cities. So I've spent a fair bit of time looking at data collection, sharing, and analysis, as well as the economic, political, and cultural forces that influence the adoption of new technologies. And certainly in terms of technologies related to data, which artificial intelligence is certainly all about. I have a couple of startups in the AI space. One of them, in fact, is responsible for the image that you see on screen, which is not, I'm a little bit unsure how to phrase it actually, because of how much production goes into creating photographs, professional photographs, and the amount of software that's actually used in them. I would argue that this image, although it is not taken by a camera, it is perhaps as real as images that have been taken by a camera and processed by software. So this is using Flux 1.1, trained on 30 images of myself, and I think it's done quite a good job, and I'm sure it's only going to get better. Sorry, just when I see a hand raised, I want to make sure that, okay, great. Okay, so I'm excited to be in the AI space. As I said, I was working on data analysis and other emerging technologies like blockchain and VR technologies, and of course AI more recently. So in terms of the way that I've structured today's talk, I've taken a little bit of inspiration from Geoffrey Hinton's talk on the weekend. My goal or my aim is to provide, and again, because I'm sure that there's quite a spectrum of comfort with artificial intelligence in the room today. There may be some people that are quite savvy technically, some people that are more in the application side and experimenting with tools. And I'm sure there are people in the room that are ChatGPT holdouts that are still not engaging with the tools. And everyone in the room is what we would call in AI a domain expert. The domain, of course, being engineering, which itself is, of course, an extremely broad field. So what I'd like to do today is to certainly talk about some of the very exciting developments that I've been looking at recently in engineering and artificial intelligence. But what I'd also really like to try to accomplish is to give everyone in the call today a little bit more of an understanding of exactly what these tools are, what they do, how they work, and some of the more sort of general ways that everyone in the room today could potentially be using artificial intelligence tools in their roles, because truthfully, it's this community that is going to shape and decide how AI is adopted ultimately in your fields. And then I will talk a little bit about the ethical concerns. After listening to Geoffrey Hinton's speech this week, his lecture this weekend, and because of my background training, my academic training, it's very difficult to be talking about artificial intelligence and not be talking about this sort of social, ethical, so the responsibilities of that we all have in adopting these tools, and certainly that is true in the field of engineering, where safety is extremely important in many use cases. And we'll see some examples of that in a few moments. And then at the end, I'll share some resources so that if you have more interest to continue exploring these tools and looking at ways that you could perhaps come up with adopting these tools yourself in your daily work, that you know where to go to get additional support. Okay, so here's me at the OSET 2024 AI Summit. I wanted to drop that in there. That's me working with a cobot in a competition to draw. And the reason why I wanted to include this in the slide deck today is because the space is moving incredibly fast. It's hard to believe everything that's even happened in the last 6 months, the advancements that are being made, and particularly relevant for the talk today, certainly in terms of vision models and AI's ability to work with imagery and to generate imagery. And we'll see that in some of the examples that I have to share with you today. So the space is moving incredibly fast, and I strongly encourage sorry, I'm going to pop up there. Strongly encourage you to be working with AI every day, even if you're not an expert, even if you don't think it's useful to you, because the truth is that artificial intelligence will be integrated further and further and deeper into our workflows as time progresses, and the space is moving incredibly fast. So, understanding AI, very briefly, I'll do this in a very light touch way. There's a couple of principles that I think are very helpful for people to understand, and in terms of thinking through how AI might be able to change your workflows if there are AI tools that are not yet developed for your specific role in engineering as an engineer, as a technologist, as a technician. Because you may very well, after today's talk or sometime next week, come up with an idea and think, oh, I think there's a way that perhaps AI could be useful in my particular expertise, in my particular domain. So I found this handy little chart, which I borrowed from an IBM website. Artificial intelligence, I was thinking today as I was preparing for my talk, rehearsing in my head at the gym, artificial intelligence is one of those terms that is extremely broad, flexible, misused, misunderstood. And I'm not sure that necessarily always matters too much, particularly when we're just really interested in, getting help from compute to perform different tasks. Do we necessarily need to all be experts on the distinction between different classes? But there is a general trend or a general arc here that I think is important to bear in mind. And of course, the first being that artificial intelligence is not new per se. It's something that's been in development for a very long time. We could argue perhaps even 75 years, depending on how you want to approach this and frame artificial intelligence. The work of Frank Rosenblatt, for example, in the 1950s is kind of a point of origin, certainly in terms of bringing artificial intelligence into the world. This is an interesting contrast with the fact that in a couple of days we will reach the 2-year anniversary of the release of ChatGPT 3.5, which was released in November 2022. So just imagine for a moment the advancements and the adoption that we've seen in just 2 years. I mean, it's really quite profound. The general arc that this graph points to, of course, is around the idea of learning and the types of learning that machines are capable of, which of course informs the kinds of tasks that they are capable of, which is what we are interested in today. What are the tasks that these machines can do for us? And generative AI, of course, being the most recent I think, stage or development in its usefulness. Later, I'll talk about what I think will happen next beyond generative AI. So very briefly, this is a slide that takes us to the beginning of the development work done by Frank Rosenblatt in the 1950s at Cornell. He had a vision for the future where machines could directly interpret the environment around them without humans provided coded inputs, like punch cards, for example. So he wanted them to be able to take inputs directly from the environment and be able to interpret them, be able to work with that information themselves. And so in this diagram, we can see a model for a simple perceptron, which has a simple neuron, which has some inputs and an output. There's a lot of math that's going on in there, and I don't think it's necessarily important to get into the math at this time in this kind of talk. The main thing to sort of look at, though, is this concept of weights and biases, which you can see represented by the W on the in the nodes here, and the bias neuron here. And I won't go too deep into what that means, but it's an important concept to sort of hang on to. Very simply, these are expressions of the strength or significance of selected input values. And these ultimately determine the output on the other side of a neural network. And adjusting these values is what improves accuracy. So we don't really need to go any deeper into it than that, although it's perhaps important to note that this work that was being done in the Cornell Aeronautics Lab, it was pushing us in the direction of computer vision, which would be relevant for the examples that I'll be showing you in a few moments. Let me see. Yeah, I think we can move on to the next slide. Okay, so here we have something. We have a bunch of neurons now, all organized neatly and nicely together, and we have a bunch of inputs here on the left side, and then we have these sort of layers in the middle, and then we have an output. The thing to note here that's important for just to have some grasping of the way that deep learning works, that neural networks function, is this connectivity between all of these different neurons. And note that each of these dots here as an input is connected to all of these ones here, is connected to all of these here, is connected to all of these here. And we have here the output on the other side. If we're thinking about the physical world, and certainly engineering is about the physical world is incredibly complex, as are even our constructed systems like language. So what we can do in compute with, say, a simple perceptron like this is not a whole lot. And in fact, potentially even with this diagram, with what's represented here, we can't necessarily even do a whole lot. But this is moving in the direction of being able to handle more complexity. And so what's interesting about this, and I'll touch on this a little bit more in a few slides, is that the goal for the neural network is to learn how to perform a task. One could be, for example, image classification. But what's interesting is that this process happens not by storing images and files and referencing those files, but rather that these weights and biases, as they are here, described here, are sort of the ways in which is the mechanism in which the networks learn how to classify images, how to perform tasks. And this is what you may have heard called a parameterized memory. So it's memory without storing the actual files. So that means that a neural network, for example, can remember or can tell what a cat looks like without having a picture of a cat stored anywhere. It's just math. And the same is true for LLMs. LLMs do not have, well, I'll explain how they can be augmented later, but LLMs do not have any text inside them. They just have math. And I don't want to go any deeper into that, but I can certainly happy to do that at another time if you're interested. So we entered into this thing called the AI winter. At this time, in this early time, you can see that this diagram is very neat and very simple. And it looks like, yeah, we could probably adjust the math in here manually or with compute. It should be fairly straightforward. But here in this resolution of this image isn't that great, but you can see this giant mess here. And what this sort of giant mess represents is is the challenge of scaling, of being able to do compute large enough, so much bigger than this, to be able to do the things that we can do today. In fact, these weights and biases, remember I mentioned their importance, that are attached to each of these circles, they in the beginning had to be adjusted manually. And so what that meant essentially is that the complexity that we wanted to do, say with image recognition, for example, was beyond the ability. It wasn't really technically feasible to do so. In fact, Minsky and Papert highlighted those limitations that people were aware of, and we had this sort of AI winter. So moving forward to this fellow here, Geoffrey Hinton, who is the godfather of AI and a Nobel Prize winner. He is responsible for popularizing something called backpropagation, which is perhaps the most significant development in artificial intelligence for deep learning, because what it did is it created it is an algorithm that automates the correction of the weights and biases in this giant mess, so that we can have advanced artificial intelligence. It's one of the keys to that. And so this is one of the examples I'll give today of why Canada punches above its weight in artificial intelligence in the world. We have a very significant role to play in that. Okay, so moving along to so backpropagation is essentially what as I said, it allows us to go in and modify these weights. And why is that important? Because our current models have billions and trillions of weights that need to be adjusted in order for them to do what they do. And it's simply technically not feasible to do that manually. And so what backpropagation does, what it does is it allows for this going backwards through these giant messes of networks and identifying where the neurons need to be changed, where the weights need to be changed in order to create an accurate output. And so the backpropagation algorithm can go through and it can iterate through and decide, okay, these changes need to be made so that we can have accuracy. Okay, So this is important for understanding the opportunities in engineering. And also, of course, we need some compute, which was contributed by GPUs. So here we have again the presence of Geoffrey Hinton in contributing to the advancement of image recognition through leveraging the NVIDIA GTX 580. So this was a significant moment as well in the advancement of artificial intelligence. So I'm going to move along because I think that's probably enough technical stuff. So finally, just briefly touching on generative AI, here's an example of a red panda holding a sign that I generated with a simple prompt. And so beyond classification and recognition, now models are able to, of course, generate new images and new text, which is what's happening when you're using ChatGPT or image generators like DALL-E, and interestingly, generative adversarial networks, which play a role in this, were proposed by a PhD researcher named Goodfellow at University of Montreal under supervision of Joshua Bengio, which is also one of the most significant contributors to artificial intelligence. So just more to the point of our role. So, I think the reason why I wanted to go through that again is because you know, there is much to be done yet in terms of developing tools for engineering. And all of you as domain experts may very well have ideas of how these tools could be used. And so having a little bit of an understanding of how they, a light understanding of how they operate technically could be helpful for those purposes. So let's take a look at a couple of examples. The first one being borehole data analysis. And so this is where we can start to see the significance of image recognition and classification and large language models. So borehole analysis allows us to study subsurface conditions. So we have these samples that are taken and then need to be cataloged. They need to be examined by experts. We need to have notes taken on them. And artificial intelligence can help with managing and producing the reports and conducting the analysis. So in this paper by Aiken et al., published recently, they're developing a model, a pipeline, a workflow essentially for being able to take images. They've trained their model on core images, and they are able to leverage notes taken from experts in order to help the process of managing the data that's collected and the analysis. And so this it can help with improved accuracy. It can result in shorter processing time, and it can allow you to get more done with less people. Something I'll touch on in when I talk about ethics in a few moments. So interestingly, here, for example, ChatGPT can take notes and can summarize the information that is captured by experts. So this is a great example of working with two models and two architectures, one for image recognition classification and one for text. So I read this paper recently about borehole coupled heat pumps. So this is related to the provision of heating and cooling to buildings. And one of the, I think, interesting things to take away from this article by Ahmed et al. Has to do with the importance of training data, which is something you may have heard of already or even discussed, depending on how much you're invested in the AI space. You've probably heard of training data and the role of training data and the significance of making sure that training data is accurate. So from your perspective as domain experts, as you're assessing and looking at integrating or adopting artificial intelligence tools, or perhaps developing them yourself, something to be mindful of is the role that's played by your training data, and the importance, or the principle of garbage in, garbage out. And so that's one of the challenges, and also opportunities for developing tools like this. This is an interesting application for drilling and completion engineering, something called intelligent well trajectory planning, which is a mouthful. I read this paper by Yang et al. That talks about the ability to adjust in real time the drilling angles. And so what this can do is offer intelligent warning of drilling risks. It can offer intelligent optimization of cement quality, and intelligent design optimization. Okay, so on the note of infrastructure inspection, this is a report was published recently by the Department of Transportation, looking at the ability to use vision through AI to conduct analysis on aging infrastructure, particularly. So there's a lot of interest at the moment, and concern, particularly in the context of aging infrastructure, to be able to identify and prioritize different assets, and to be able to determine and ascertain and predict future risks for further deterioration. And so you can see here these images that are used for training data to create the ability, for example, an inspector to capture real-time image input of infrastructure, and to be able to get informed opinions from artificial intelligence on the nature, the concerns, the severity of the compromised assets. So this is allowing the assessment, for example, of reinforced concrete structures. You can look at cracking, crack widths, patterns, and orientations. Let's see if there's anything else I want to share here. No, I think that's okay for now. So this makes the new designation from OSED, for example, launched this spring, is relevant in this context, because much of the infrastructure is under the responsibility of municipalities, and so you know, there are concerns around the collapse of infrastructure, more broadly speaking, around bridges, for example. There's quite a lot of concern about aging infrastructure. And I found this really interesting video here. I'm going to try, it's just a 30-second or 15-second clip here. So to visualize some of the capabilities of being able to leverage artificial intelligence in this particular way. So this is an input of approximately 300 bridges. This is research that's done by a spin out from Oxford. Let's see if this will play. Yeah. Okay, so you can see here a sort of visual demonstration of what I've been talking through so far. We have this input data that is used to train the models so that they can then start to be able to not just classify, but then potentially predict future degradation. Okay, so in terms of transportation, for example, intelligence transportation systems. This is an interesting development that I've read about, a graph attention tokenization for vehicle trajectory prediction for roadway safety. So essentially, there's work being done to be able to predict the trajectory of vehicles in order to avoid collision, for example. Another interesting development is liquid neural networks, which there's some research coming out of MIT recently about, and this is quite interesting because liquid neural networks, typically when we talk about neural networks, they are trained, and then they're not modified, they're not changed anymore. So we tend to recognize them as a static data set, although they can be augmented, and I'll talk about that in a moment. But liquid neural networks are quite exciting because they do have some ability, because of their specialized architecture, to have their parameters. And remember that the parameters are the things that allow us to have an accurate output in neural networks. There's sort of the learning mechanism that they can, in fact, in some ways be adjusted slightly. And so the example that's provided is, in this case, is drones. That models maybe that were trained for an urban setting could, in fact, learn and adapt themselves to being used in, for example, a forest setting. There's some really cool videos if you look up this research project of drones flying through forested areas to locate objects that are in forested areas. One of the sort of the mechanisms for this is that the models are developed in such a way to ignore a lot of noise. So a pretty exciting and interesting development. And finally, for examples, robotics. This is Figure for those of you that are not familiar. This is a recent release, I think just a couple of days ago, in fact, some updates on the capacity of robots in partnership with BMW to automate in the factory. BMW is an interesting case. They've spent quite a lot of money investing in emerging technologies, in artificial intelligence, and in virtual reality. They actually have what's called a digital twin, which is a replica of one of their manufacturing plants, where staff are able to actually train for working on assembly lines in what is a direct copy of the assembly line. And what they found is that there's actually an improvement in efficiency and reduction in error as a result of those training opportunities. So I also saw an interesting paper that is talking about adding in more visual models, visual inputs with other sensor data to help with the grasping and the manipulating of physical objects to improve on that accuracy. Okay, so I wanted to talk a little bit about AI for everyday because it's possible that perhaps that there isn't necessarily an application for your specific use, for your specific workflow. But what I wanted to sort of inspire or provide is some thought around, what are some of the AI tools the AI tools and tasks that are possible at the moment, that then you could perhaps think through a way that you could leverage some tools that are readily available for some of your workflows yourselves. And so I have a couple of things to talk to here. So large language models being the first and obvious, although I've spent a lot of time talking today about visual models. I imagine that many of you at this point have already experimented with ChatGPT in some way. One of the ways that I use it and find it quite fantastic is for processes like summarizing documents or preparing new documents, evaluating policy documents, and engaging in conversation by leveraging additional abilities within LLM. So in early days, we would likely get a kind of sort of enter a document and ask a question perhaps, and we get a response. The ability to interact with documents is improving rapidly. And so I would encourage you to check out tools like Google Gemini, for example, and ChatGPT, that you can have conversations with the chatbot, with the LLM about the documents that you're providing. And there are some specialized tools as well that you may be interested in experimenting with. But also, there is quite a lot of integration with existing software. So what we're seeing is products like, say, Adobe Acrobat, for example. If you are using Adobe Acrobat recently, you might have noticed these sort of little lights and little circles highlighting these new features. And those features include things like being able to have a conversation with the software about the document. One of the early tools that I found is called Charlie. I came across this well over a year ago, which in AI time is like 5 years. But this is a really great tool because what it did is it kind of prompted and helped people with their workflows. So you could, for example, give it 5 technical documents that are related to each other, and the tool could analyze the documents. And based on that context, it would pop up questions that it is anticipating that you might like to ask to deepen your understanding of the material that's there. And so in this way, we start to think about this idea of co-intelligence, which I'll touch on lightly in a moment. But in terms of working with text, the advancements have been really quite remarkable. And I strongly encourage you to, if you haven't already, to not with personal data, of course, but to start inputting your documents into these tools and getting help with surfacing significant points, surfacing themes that are across different documents, and also, of course, for help with writing them. Okay, so move a little here. I showed you the image earlier of myself. This is an image generated by a model fine-tuned on myself, on my headshots. Language models, of course, can also be fine-tuned. So there's lots of chatbots that you can make that may be useful for you. Maybe not directly for an engineering task per se, but could help you with other related items and administrative work as well. So the advantage here is that obviously building a new model is not something any of us on this call is going to be doing, but we have the ability to sort of fine-tune these models for our specific purposes. So more to my point of hoping that after today's talk, everyone can walk away with perhaps at least one idea of a way that you could leverage an AI tool for your own workflows. So this is a very important advancement called RAG. Again, highlighting Canada's role in artificial intelligence. The individual that proposed this is working at a firm in Toronto called Cohere. And so what this does is it allows you to access private databases, which is very useful when you have information that hasn't been put into large language models. So this is where we start to get into this idea that large language models aren't necessarily static, that they can be updated, that they can be modified. And this is also happening with images as well. So you could start thinking through opportunities to train your own models on images that you have relevant to your own workflows as technologists and technicians. And I have something I'll share about that in a moment, an idea I've been working on with someone. So I'm kind of moving through the time quickly here. So I'm just going to move a little bit faster for these last few slides. Reasoning is something that if you're listening to podcasts and following the AI space, this is the idea of multi-step workflows. For a lot of people, they use models as vending machines, I call it. You push a button, you get what you want out, and that's it. What we are seeing here is the movement towards being able to take multiple steps in a workflow. You can experiment with OpenAI Canvas as well, but also its newest model, the O model. The reason why this is the last thing that I wanted to. Second last thing I wanted to mention in this section is the idea of agents. So this is looking a little bit more into the future. And you can see Agent Smith here. It's my contention and the contention of others that 2025 will be the age of agents. So what we've seen for the last couple of years is that generative AI is certainly what everyone thinks, most people think about when they think about artificial intelligence. And we're going to be moving into this new stage where AI tools are not just classifying, not just producing answers, not just generating new images, but that they're able to actually go and execute on tasks. In fact, Anthropic just released this week a new protocol that is going to support that, to facilitate that, so that we can connect agents that can execute on tasks to different data sources. So would recommend paying attention to that for in the near future. This is certainly something that's going to disrupt workflows and is also a significant opportunity. Okay, so smart wearables. You can imagine thinking back to the infrastructure analysis, inspection. Glasses may play a significant role in this. I've been discussing with someone the potential of developing their own database of images that could be used with a RAG system for helping their technicians in the field to perform analysis. And if you want to hear more about that, you can reach out to me. I'm going to move along just to very briefly touch on ethics, because I don't want to leave without that. Okay, so ethics, we have this concept of algorithmic accountability. Of course, there's certainly my understanding of the ring that is given to engineers. It has a story to deal with a project gone wrong. So one of the things that is a significant discussion and cannot be overstated is this idea of algorithmic auditing and making sure that we understand what's going on inside these tools, so that people are kept safe and that we are not completely displacing the role of the expert, and that we continue to have humans in the loop. Privacy is an ongoing concern. So as I mentioned, don't put personal data that you're not authorized to share into large language models. Fortunately, we have lots of policy in place, and privacy is not necessarily a new thing. There's a development of privacy as a concept stretching back well over 100 years. And we have some recent developments, or current developments you can follow if you want to know a little bit more about that. Bill 194, which received royal assent in Ontario a couple days ago. Labor force concerns, obviously. What do all of these tools mean for our labor force? Do we have fewer people with the same productivity, or do we have the same amount of people with more productivity? And something to think about also is if there are no junior associates because they've been replaced with agents and artificial intelligence tools, who then becomes the senior associate at some point in the future? Are we risking a potential gap in skills at some point in the future? Of course, we can't get away without talking about environmental impact, resource consumption. Many of you may have heard this sort of stat that it takes a bottle of water to produce every email written by ChatGPT. We have concerns around the energy consumption, and is there enough energy available? Can it be supplied for these large data centers? So that's another. And then, of course, additional concerns like deepfakes, the de-skilling of labor, the harms to data labelers and superintelligence gone rogue, and more. Okay, so finally, resources very quickly. If you are interested in catching up on artificial intelligence more broadly, these are some great resources. These are some of my favorite podcasts. Really incredibly difficult to keep up on everything AI. It's simply not possible for one human. There's just too much going on. So these are great resources. If you're a big fan of LinkedIn, Jacqueline Konzelman is the product lead at Google. She's a fantastic resource, University of Waterloo grad. This is a wonderful book and source, Ethan Mollick, to think through working with AI tools. So rather than thinking about them as replacing us, how do we collaborate and cooperate with them? Highly recommend this book and following Ethan. He's an incredible professor from Wharton. And then finally, if you're interested in going even further and actually learning how to work with some of these tools, if you're not already, Weights and Biases is offering some really fantastic free online courses. I took one on advanced RAG development recently. It was fantastic. Highly recommend that you check them out. Okay, so cognizant of the time, we have just a few minutes left, and I want to make sure that I have a moment to look at the questions in the chat. 100 new messages. Okay. Wow. Okay. So let me see. I'm just going to jump in and see. Oh, in the Q&A here. Privacy concerns. Yeah, absolutely, Marcus. Yeah, Zoom transcription feature. Yeah, so this is a great question because again, I kind of felt when I was preparing this talk that, in one sense, artificial intelligence in engineering and the use by technologists and technicians, there's very specific tools that are designed very specifically for very specific tasks. But more broadly speaking, we also have all kinds of ways that we can just use them in our everyday workflows. And certainly, video recordings like this and chat GPT usage, there certainly are privacy concerns. And I think that what you want to do is just be very cognizant and ask permission as much as you can in that regard. Yeah, that's it. So someone has asked about the PEO and stamps reports when they're done, who stamps the work. Yeah, very important question. And I think that at the moment, a general sort of approach is that humans have ultimately the responsibility at the end of the day to sign off. So that's the approach that I'm certainly sort of taking at this point. I think we've got just a few more moments, so I'll see if there's another question I can answer, and then I'm going to have Trent wrap us up. So Christopher is asking about getting more educated. That's great. That's fantastic. So the resources I shared hopefully point you in the right direction. You can also, if you want further resources, you can reach out to me on LinkedIn, and I'm happy to point you to a few people that can keep you updated. I'm sure that there will be more course offerings available through your associations. Okay, so I think that's probably pretty good. I don't know, Trent, if you want to wrap us up and take us out.
Yeah, thanks, Michael. And wow, what a great presentation. I learned a lot myself, and I think I'm going to go and do some online studying through that Weights and Biases book because it's truly amazing. And I'm quite enthralled by the pictures and the X-ray, or not X-ray, but the imaging for the bridges. That's quite something. So, yeah, but thank you, Michael, on behalf of everybody at TPC and everybody online. That truly was an excellent presentation. As you said, I guess we're kind of at the end here, and just want to thank you once again for sharing your expertise on today's webinar and providing us with some really specific insights as AI relates to the world of technology. So, congratulations. Thank you very much. Thank you, everybody, for joining us and celebrating NEAT Week. And I wish everyone the best for the rest of your day and week. Take care.
Thanks very much. Bye.